So let's start with a familiar picture, could even be an Excel spreadsheet. In this case, maybe I can show also. In this case, I have, let's say, 10,000 patients. Well, sometimes I don't have that many, but just for the sake of it. Code P1 to P10,000. That has a certain age, 35 years old, 40 years old, 55 years old. For each one, I have weight, the current weight, his smoking habit, heavy, light, or no smoker. And the last column here is whether or not this patient has developed cardiac heart disease. Okay, so this is an after-the-fact sample. Okay, our mission here is trying to understand the relationship between those three attributes, age, weight, and smoking, and the CHD. In order, first of all, to produce this sample out of the data, we will use ontologies and medical queries to isolate these 10,000 patients from potentially many, many more thousand cases that we have in the database. And of course, our data could be vertically integrated. In other words, I could even have here a gene attribute coming out of genetics, and the system will not matter. Anything you like could be an attribute. It doesn't have to be numeric. As you can see, it could be ordinal, as it's called, and could just be numbers.
So there is a decision on the kind of data. You decide first how to classify.
Right. You decide how to represent each patient, basically. Of course, a patient has many more attributes. Here, for the sake of the example, I only show 3.
And this is a medical representation, the way doctors look at the patients in general.
Very often, the doctors will work quite like that.
Yeah.
Now, I can be looking at these 10,000 cases, or maybe 100 cases, for many hours, okay, and trying to discover relationships between the attributes and the outcome. Okay, and we have here the computer trying to do in a way that you can follow and intervene. That's the value of AITION, and find the AITION that is the cause of those things with respect to the selected attributes. So sampling was the first step. The next step is now to enter the system, the AITION system, and generate through a machine learning process, a graph model. Okay, so what happened here is that the system processed all these attributes, characterized here with blue, and then it linked them with the orange attribute, which is the outcome. So the meaning of this graph here is that according to the data, and be careful, only according to the data, age affects CHD. It looks like weight affects CHD. And smoking affects CHD. But there is also a relationship between age and smoking,
yes,
weight and smoking, which may look surprising or maybe not. First of all, as a small child, it's unlikely to have a heart attack, right? So obviously, as you get older, the likelihood of a heart attack will increase. Second, if you're a small child, probably you don't smoke. Now, the relationship between weight and smoking is interesting, and in fact, we'll see in the next example what we do with that. Okay, so in summary, the graph model derived from this sample shows that there is a relationship between age and weight. In fact, age and weight appears to determine smoking, and age, weight, and smoking together appear to affect CHD.
And this is mechanical.
And this is automatically generated.
Yeah, automatically generated.
At the place of the dots, I didn't want to confuse you here, but there will be probabilities. Okay. In fact, if I am, let's say, age 15, what's the probability to get CHD? Okay, according again to the samples. If I'm a heavy smoker, what is the probability to have CHD? If I have age 5 and I'm a heavy smoker, what's the probability to have CHD? All of those things are recorded here, okay, and computed again based on the sample. So what we claim here is that this 10,000 rows of data has been compressed, summarized into this graph, and this is one of the values of the tool.